Welcome to the statistics. In this class, we are going to learn about harmonic mean. Harmonic mean is the reciprocal of arithmetic mean of the reciprocal of the given values. For ungrouped data, let x1, x2, x3, and so on xn be n observation. Then harmonic mean is given by 1 divided by n summation 1 divided by xi. A person travels from Hyderabad to Vijayawada at 40 kilometers and returns at 60 kilometers per hour. Find the average speed. So that is 2 divided by 1 divided by 40 plus 1 divided by 60. That implies we got the harmonic mean as 48.7. Approximately he traveled in the speed of average speed, that is 48.7, in the sense 49 kilometers per hour. Okay, calculate harmonic mean to the following data. So that is 3 divided by 1 divided by 2 plus 1 divided by 3 plus 1 divided by 4. So that implies 2.77. For group data also we have to calculate 1 divided by fi divided by xi. So that implies group data in the sense discrete with frequency observations. So we see distribution of marks obtained by the students in a class given below. Calculate harmonic mean, marks and number of students. Okay, 20, 21, 22, 23, 24, 25, and the frequencies are 4, 12, 15, 20, 11 and 8. So we have to do fi divided by xi, that is 4 divided by 20, 1 divided by 5, that is 0.2. Like that, 12 divided by 21, 0.57, 15 divided by 22, 0.68, 20 divided by 23, 0.86, 11 divided by 24, that is 0.45, and 8 divided by 25, that is 0.32. Capital N equals to 70 observations. 70 divided by 3.08, we got 22.72. That is 72. Find the harmonic mean to the following data. Okay, this is also be the discrete frequency type of data. X equals to and f equals to the given, that is x and f data, discrete with the frequency data. Same formula we have to apply. 1 divided by capital N, n divided by fi divided by xi. So here we got the solution like this: 54 divided by 6.5376, that is 8.2576. For continuous frequency data, we have the class intervals in the frequency. Okay, likewise you have to calculate what is the formula. Same formula we have to apply, that is capital N divided by summation fi divided by xi. Okay, this is how we have to calculate for continuous frequency data and so on. Next, the merits of harmonic mean and the demerits also we have to discuss. It is based on all the values. It is defined rigidly, and it is not affected by the fluctuations of sampling. It is suitable for the mathematical treatment. Next, the demerits. It is difficult to calculate. It is not easy to understand. Smaller items are given more importance. Okay. So similarly, we have the weighted arithmetic mean calculation also. Okay. Here the weights are given just like our frequencies. You have to do a discrete frequency data and the calculations like that. You can see this one also. Next, uses of weight mean and all. Next, measures of dispersion. Okay, dispersion means the scatteredness or the differences. Measures of dispersion is a study about homogeneity of the given data. Okay, distribution. It studies to have an idea about the variability spread in the data set. Okay, how the data is moving, they want to know. So that time we have to use the measures of dispersion. Marks of two students in three different tests, T1, T2, T3, and average they given. The mean of marks for the both students are same. Okay, we are likely to conclude that these performance are same, but it may be observed that variability in the marks of a student A and is more than, okay, that of B. The measures of central tendency, mean, median, mode are not capture of dif- uh, detecting this, okay, difference in the variability or spread in the data sets. In order to have the complete of data set, statisticians used uh, some measures of dispersions. They are the measures of variations also we are going to call it as. Next, characteristics of an ideal measures of dispersion. According to the professor J.U. Yule, a good measure of dispersion should have the following. First one, it is easy to understand, it is easy to calculate, it should be rigidly defined, it should be based on all values. Its computation procedure should be simple. It should be capable of further algebraic treatment like that. Okay, we have common measures of dispersion. They are range, quartile deviation, mean deviation, and standard deviation. Measures of dispersions are majorly divided into two types, that is absolute measures and relative measures. Range, quartile deviation, mean deviation, and all. Relative measures also we are going to see. Range. What is range? Range is the difference between the highest and lowest values in the data. That is, range is denoted by the capital R. R equals to maximum value minus minimum value. For discrete data we have the calculation. Okay, for discrete frequency data also we have the calculation, and continuous frequency data also we have the calculation. Find the range of the value 50, 65, 90, 45, 20, 80. Maximum value here is 90 and minimum value is 20. Range is equals to 90 minus 20, that is 70. Okay, find the range for the given data, maximum minus minimum. What is the maximum value here? 300. What is the minimum value here? 75. So that is the range of this data is 225. Next, merits and demerits of this range. It is easy to calculate, it is simple to understand, it is useful in statistical quality control, forecasting, and price analysis, etc. Demerits of range. It is based on only two observations. It is a very rarely used measure. It cannot be calculated for open-end classes. Yes. Quartile deviation. What is quartile deviation? Before going to quartile deviation, we should learn about the quartiles. It is defined as the half of the difference between the lower and upper quartiles. It is also known as a semi interquartile range. Okay, that is q3 minus q1 divided by 2. Okay, what is q1? First quartile. What is q3? Third quartile. If n is odd, then you can use the formula of n plus 1 divided by fourth observation for the first quartile and 3n plus 1 divided by 4 for the second quartile. Okay, first step number 1, you have to arrange the given observations in a ascending order. Okay, here the given observations 8, 2, 4 and so on. Okay, here they given 8, 2, 4, 15, 11, 10 and 9. So after arranging in increasing order, the observations become 2, 4, 8, 9, 10, 11, 15. So from that I need to calculate the quartile deviation, that is Q1. What is the formula? Here n is an odd, 7 is an odd, 7 number of observations are odd. So we can add plus 1 divided by 4. Observation is our Q1. 7 plus 1 divided by 4th observation, that is 8 divided by 4, that is second observation is our Q1. So what is our second observation here? That is 2 comma 4, that is second observation is 4. So Q1 is 4. Similarly, calculate the third quartile. 3 into n plus 1 divided by fourth observation, 3 into second observation, that is sixth observation. What is sixth observation here? You can see 1, 2, 3, 4, 5, 6. Sixth observation is 11. So that Q3 observation is 11. Therefore, for the quartile deviation, we have the quartile deviation calculation, that is 11 minus 4 divided by 2, that is 7 divided by 2, that is 3.5 for the given data. For the given data, the quartile deviation for the given data. Okay, you have to calculate some more in the next session. Thank you for this. Thank you.